Okay, in this week we will continue with the Bayesian Decision Theorem. This is the main title, and so the probability is one of the basic fundamentals concept to represent the events. But which events happen for a given condition? Okay? There must be a condition, always, guys. And so, in a mathematical perspective, we need to write these notes in order to understand after the lesson perspective. And so it's basically a transformation a line into an area. Just remember the previous lesson, guys, okay? Which is shown as probability rate of event, which means that we directly utilize the area, not the line. Just remember the previous lesson, we have talked about it, because for a given any conditions, and so we may expect to what to happen an event, not a deterministic or the decisive line. Okay? So in order to understand the probability, understand the probability distributions, we need to analyze the subset of class. Which means that we create the C1, C2 and C3, supervised or unsupervised, it doesn't matter, but we need to analyze for a given one-dimensional data or two-dimensional data based on these concepts. And so the collection of these concepts must be equals to the what? It's equals to the 1 or 100%, guys. Okay? But which one is highest or lowest, we don't know. So we should create the axis in here, just like this one, the n, and so the 80 and 100 and 120, and also we have maybe 300 data for a given x values. Okay? And so the distribution of this data is just like this one. Okay? And so we have one boundary condition, this is the mean condition, and this is the outer condition for this case. And so we can easily check the data distribution. Maybe this is the C1 class and this is the C2 class. This is the transition area. Okay? And so we can write that this is for a given or in the presence of the x value, we can call it as presence or existence data. Okay? So if we condition these distributions we may presume or assume that the x must be exist in here. Okay? And so, for the classes, we can create this form, like this one. For example, we have the C1 class in here, and we have the C2 class in here, and also we should draw the main circle in here as an x, because the C1 and C2 is only happens at the at for a given x, or the present or existence of the x. Okay? And so if we condition this value just like this one, this is the 0, and the outer dimension is 80, and another dimension is 120, and also this is the 300s. Okay? So we can divide this x data in the in the C1 and C2, but the x is bigger than that. Just remember that. Okay? So we can conclude that the event of x is entirely dependent on any other things, not the C1 or C2. X is dependent on the another property, which we don't know. Okay? Which means that in order to analyze the C1 and C2, we need to assume that it is to Px is equals to the 1. But if we know the Px, for example, 0.5, this is the the precondition. But if we have only information about the x for a given this class, and so Px must be equals to the 1. Okay? And also, just remember the probability conditions. This is the the C1 combination C2 must be equals to the the Px in here. Or we can write P C1, probability of the C1, probability of the C2 minus probability of C1 intersection C2. Okay? And so this condition generalized to the x creates only C1 and C2, but not the other one. Okay? So in this case, we need to define some important properties or the definition in the in the probability theory, which is called conditional probability. Okay? Now we have two subsets, C1 and C2, in here for a given x. Okay? So how can we connect these two classes? Firstly, in order to understand the conditional probability, firstly, we need to talk about the Euler diagram of any case. Can be given by with the with this general notation. Just like in the previous section, we can call it the the omega in here. Okay? And also we can draw the A class in here, and also B class in here. B is contained in the what in the A, and also this is the B1, and also we can draw the what, this is the B2, and this is the what, B3. And also its existence probability is assigned to the what, this is the 0.1, 10%. This is the 0.3 is the A, is the 30%. And also this is the 0.12, this is the 0.04, and this is the 0.1, and this is the 0.04. Okay? This is the probability. The rest of the omega term is assigned to the what? The 0.04. Okay? So, we should calculate the total probability. Probability is equals to the what? P omega must be equals to the 1. The collection of the whole terms must be assigned to the 1. This is the preconditions. Okay? Secondly, the probability of A given omega is equals to the what? PA can be calculated with the what? This is the 0.3 plus this is the 0.1 plus this is the what? 0. This is the 2, 0.2, which is equals to the what? Which is equals to 1, 2, no, I'm sorry, this is the 12, guys. 12 okay, and this is the 112 and 0.52. okay, this is the probability of happening of a what? Of an A for a given omega. Okay, or we can write this condition just like this one: A for a given omega which is equals to what? 0.52. okay. So how can we calculate the another terms in here just like this one? For example, the probability A for a given B1 which is equals to the what? P A for a given B1 which is equals to the P A intersection B1 divided by P B1. The happening rate of the probability rate of happening the B1 is equals to the what? Is equals to the 0.1, because it's the chance to what? To happening B1. And also the A contains the this one, and so the intersection is equals to what? 1, which means that this is equals to the 1. Okay? We can calculate just like this one, these values. And also we can write the what? The probability of A for a given B2 is just like this one, PA for a given 2, which is equals to the what? The intersection of the A intersection B2 and PB2, which is equals to the what? A contains only 0.12 in here for a given A, and so the PB2 is the collection of the what? The 0.15 plus 0.04. The total probability rate is calculated in here, and so this is equals to what? The 0.75. okay. So this is how we can calculate the conditional probability. What is condition? Condition is that the omega values. Condition is that the B values. And so for a given B value, what is the probability of the A? This is called this one. Okay. And so this is the conditional probability. And in general form, we can write this one: P for a given omega, which is equals to the what? The P intersection B of omega divided by P omega. Okay? This is the conditional probability. And so, we need to return to the what? To the graph. Now, return the graph of X and represented by this one. So this is the X which is given in here, and this is the sampling number, and also we should draw the points in here just like this one. Okay, and so this is 80, this is 120, and 300 is given in here. And so we have the one class in here, C1, maybe short, can be assigned in here. Maybe this is the what? The C2, this is the tall. Okay? We don't know yet. But in this case, we should assign 400 in here. This is the N. And so we can draw the Euler diagram just like this one. We have C1 class and we have C2 class. The outer class is the X, and this is the C1 and this is the C2. And so what is the probability of these terms in here? And so we need to fill it, just this one. But how we can do that? We need to define another property, prior probability. Önsel. And so, how we can build the prior probability? Assume that in the first case, Px must be equals to the 1, because we don't know the x is coming from, but we may know that this diagram is contained in the what? The n for a given the x. And so we need to consider that the probability of happening x in this case is equals to the what? Is equals to the 1. Okay? So, we need to calculate it now. Probability of C1 and C2. C2. But the prior should be assigned or calculated by with the what? P C1 is equals to what? Only 880 values is given in here, and so 80 divided by 400, because we have only 400 data in here, which means that this is the 1 divided by 5. Okay? And also PCQ is assigned with the what? We have totally 400 data, and minus we have 120 to 400 data, and so this must be subtracted in here for a given 400 data, and so 28, 40, which means that 14 or 7 divided by 10, or this is the what? 2 divided by 10. Okay? And so what is the probability rate for a given x in the what? In C1, which is equals to the 0.2. And so what is the probability of the C2 for a given x, which is equals to the what? 0.7. Okay? And the other rest term is equals to what? 0.1, because we assign to the x is equals to the what? Is equals to the 1. And so this is the probability rate of the what? The undefined behaviors, which is given in here. Okay? So this information can arbitrarily be selected by users, but the estimation of the probability is affected by this choice. And so, the general formula for the what? For prior information or calculation of the prior probability is equals to the what? Number of class data and we need to divide it to the total number of data. We can easily calculate to the prior information for a given data set in here. Okay? So, in the third place, we have talked about the likelihood probability. In the previous lesson, for the expectation maximization algorithms, guys. Just remember that, okay? But in this case, we turn into the different definition of this likelihood probability, okay? And so the likelihood probability is a now conditional probability. Okay? With the assumption of to what? Firstly, assume that each class, tall or short, for our example, is to what? Is follow normal distribution. Just remember the previous lesson. We have talked about to the what? To our cases. With the what? With the mean values and standard deviation formula. Okay? And so it's concluded with the what? With the estimation or the estimate. Formulate the model based on to what? The mean and standard deviation values. Okay? And so in order to calculate these two parameters, and so if we use the mu and standard deviation, mean or standard deviation, following to the what? Normal distribution, we can calculate the likelihood probability. Okay? Benzerlik. So we can calculate to the what? To this one, P, X, C1. Now, C1 is a class, but we should deduce the values of the X, and which means that, in a simple manner, this is code for a given C1 class, or the short class. What is the probability of the X? In a Turkish, ben Türkiye'den bir tane insan seçersem kısaların arasından, bunun Türkiye'de olma ihtimali nedir? Ama bu sefer Türkiye'yi bilmiyoruz. Sadece klası biliyoruz. Yani kısa insan seçersem dünyada, bu kısa insanlardan birinin Türkiye'de olma ihtimali ne? Aslında bu böyle bir şey. Diğerinde veriyi verip klasın içindeki değerini araştırıyorduk. Ama burada ne yapıyoruz? Bu sefer klası veriyoruz, tanımlı şey veriyoruz. Bu x'lerden kaçı buna giriyor? Bunu hesaplıyoruz. So, in this case, we need to build this one, x intersection c1 divided by p c1, right? For a graph, we have a 0.2 in here with the definition of the x, and so this is called 0.2 divided by 0.2. This is equals to the 1 for a given this class. But you should know that these values are trained, or we know it. Because this definitions is coming from the what? The graph, and so this graph should be contained with what? With this one, because the C1 is only contains to the what? To the contained with the what? With the x values. What if we have the y values in here, and so this is diminished, or the lowest way on this case, okay? And so the x C2 is calculated with what? The p x intersection of the what? The C2. And so the p C2 can be written For a graph, this is equals to what? 0.7, 0.7, and so this is also 1. But we know it in here. Okay? In Turkish. Bakın arkadaşlar, biz burada önsel olasılıkları bulduk ama şu ne anlatıyor? Bakın C1 var. Herhangi bir C1 sana ben verirsem bunun X olma ihtimali ne? Bakın şimdi bu grafiğe. Herhangi bir C1 verdiğimde size kesinlikle X olacak bu. O yüzden 1. Herhangi bir C2 verdiğimde de burada X olacak. Ama Y diye bir değişken olsaydı ve bunlar paylaşsaydı o zaman bu böyle olmayacaktı arkadaşlar. Asıl konu bu. Ama bunu da birazdan tartışacağız. Okay. So, in order to re-evaluate new X data in here, using this form, we propose to what? Normal distribution, guys. Which means that if we propose the X for a given C1, and so we can write the what to these parameters or the formula 2 pi sigma 1 square times exponential terms with the what minus X minus mu 1 divided by 2 times sigma 1 square. Okay? For new data, we calculate the probability rate of this X for a given C1. Okay? Or Px C2, it is derived with the what? With the same formula. But now sigma 2 square exponential terms minus X minus mu 2 square 2 times sigma 2 square. Okay? For example, if I have these parameters, maybe mu1 is assigned in here, mu2 is assigned in here, and so I should put the data in here, data in here, data in here, and data in here. Maybe this is the what? This is the C2 class, because for a given C2, this X values probability is represented based on this formula. Okay? This is called likelihood. Benzerlik. In Turkish. Şimdi bakın arkadaşlar. Bizim herhangi bir klasımız varsa, yani sınıfımız varsa, bunu standard deviation, yani standart sapma ve ortalama değerle modelleyebiliyoruz. Eğer biz bunu modellersek ne diyoruz biliyor musunuz? Herhangi bir sınıfın verisini bu şekilde verirsem, bunun içerisinde bir X olabilme ihtimali, yani yeni bir veri buraya koydunuz, bu klasa göre değerlendirmek istiyorsunuz. Bunun içinde mi değil mi? Aslında buradaki olasılıktan öğrenebiliyorsunuz. Buna da benzerlik diyorlar arkadaşlar. Konu bu. Yani senin elinizde bir önsel olasılık var. Prior probability, bir de likelihood var. Likelihood'u bakın biz ne yapıyorduk? Zaten bir önceki derste Gaussian Mixture Model ya da atıyorum Normal Distribution'dan zaten biz bunu çıkarmıştık. Şimdi bakın bunları ne yapacağız? Bir önsel olasılığı, bir de benzerlik oranını burada, benzerlik olasılığını burada çıkararak aslında bir tane teorem yaratacağız. Bu sizin bildiğiniz çok meşhur aslında bir teorem. Okay. In this case, we can write to Bayes theorem. Firstly, let's turn into the following shape, just like this one. This is the X, C1 and C2. This is the class. So we get the what? This one. Px C1 is equals to the what? Px intersection C1 divided by P C1, and also P C1x can be written just like this one. P C1 intersection x divided by Px. This is the basic theorem of the what for a given conditional probability calculations. And so just see that in this case we can show that this one P x intersection C1 must be equals to what? P C1 intersection S. This is identicals. Okay? And so we can rewrite the formula just like this one. P x intersection C1 is written as P x for a given C1 times P C1, right? And so if this is the case, and so we can put this term into the what? Into the this one. And so the final formula is called P C1 x is equals to the what? P x for a given C1. This is the likelihood, and this is the probability rate of the C1, and so this is the Px. And so this is the famous theorem of the Bayesian theorem. Okay? And also this is what? This is the prior probability. And also this is the prior probability. But this is what? This is the likelihood. Just remember the expectation maximization algorithm. We always calculate to the what? To the likelihood based on the normal distributions. And so if we have any data for given the x, and so we can divide the classes C1 and C2. And so if we are using the prior probability and the likelihood, we can calculate to the what? To posterior probability. In Turkish, sonsal olasılık. Okay? So we can summarize the whole terms. The posterior probability is to what? P C1 for a given x. And so in detailed meaning, we can write to the what? The probability of C1 given to the what? New x data. And so this must be called the classifier, right? We can test any new x data for a given the C1. And so if this is the probability is the high rate, and so we can call it that this x should be C1, should be tall or short in here. Okay? The same idea is applied to the what? For C2 as well. P C2 for a given x, which is equals to the what? For a given Px, and so Px divided by, or no, for a given C2, P C2 can be written in here, just like this one. Okay? And so in this case, this is the probability of C2 given to the what? New x data, guys. Okay? This can be built with the what? With the bias classifier based on this information. Okay? So, in Turkish. Şimdi bakın arkadaşlar, biz eğer ki burada şartlı, conditional bir probability oluşturabiliyorsak bunu kesişim kümesi ve verilen class'la alakalı yapıyoruz. Bunu anlatıyor. Siz bunu C1 için verilen bütün x'ler için ya da x için verilen bütün C1'ler için yapabilirsiniz. Ama bu formülasyon değiştiğinde sadece alt kesim değişiyor. Üstündeki kesişim değişmiyor. Çünkü biz biliyoruz ki bunların kesişimi kesinlikle aynı olmak zorunda. O zaman ben gidiyorum bu iki formülü birleştiriyorum ve diyorum ki burada Px benim ön koşulum, prior probability, Pc1'i de ben zaten ön koşuldan biliyorum. Ama benim burada bir modelim var. Yani siz eğer ki elinizde bir önsel koşul varsa ve bir tane modeliniz varsa herhangi bir x değeri verildiğinde bu C1'e mi ait değil mi siz bunu bulabiliyorsunuz. Buna Bayes teorem deniyor arkadaşlar. Yani kulağınızı mesela sağ taraftan tutarsanız sol taraftan tekrardan kulağınızı yine tutabiliyorsunuz. Tam tersini yapabiliyorsunuz. Olasılığın öyle bir yanı var. Yani olasılığı tersine çeviriyorsunuz. O yüzden biz bunu eğitebiliyoruz. Şimdi size aslında onu göstereceğim. Okay. In the literature, we have some important classifier. It's simple but highly effective. Navy bias classifier. Based on the Bayesian theorem, guys. Okay? 1 minute. Okay. Up to now, we learn to the bias rule. Okay? And the implementation of the probability result using the proposed model. And we show that either we can calculate the x probability or the class probability. And so, but we can convert or transform these two probability into each other. Okay? So, this bias rule can be utilized to classifying data into specific classes, okay, which we call it Navy bias classifier. Okay. So, in the Navy bias, in the literature, Navy is what we have strong assumption. What is the meaning of the strong assumption? If we propose two classes for a given x, which we can assign to the two classes collect or creates the whole x. Okay? There is nothing more. There is no C3 class, C4 class. In Turkish, eğer ki iki tane sınıfınız varsa arkadaşlar C1 ve C2 x için, bu x ya C1'dir ya C2'dir. Aslında size bunu anlatıyor. C3 yoktur arkadaşlar. Okay. And so, using the Bayes theorem, we can write to the P, C for a given x can be built with the likelihood x for a given C times P, C divided by with the Px. Okay? So, this x is the existence probability rate of the x. And this is the class probability rate. Prior rate. Okay? And so, this is the likelihood. And then what? We should write the assumptions. Just like this one. The features are conditionally independent for a given class, which you can say that either C1 possess this x or C2. Okay? And also we should assign the prior probabilities are known. C1 and C2. Okay? In Turkish, arkadaşlar, eğer bir veri C1'de ise C1'dedir, C2'de ise de C2'dedir arkadaşlar. Bunu anlatıyor ilk assumption. İkincisi de arkadaşlar, siz C1'in ve C2'nin oluşma olasılığını biliyorsunuz. Bakın burada dikkat ederseniz x zaten px burada 1 değerinde. Yani bunun oluşacağını biliyoruz. Ama ben 0.5 verirsem buraya bu x ya oluşur ya oluşmaz. Böyle bir olasılığı var. Ama siz diğer durumları bilmiyorsunuz. Okay. Let's say x1 and x2 are two features in here. Let's say x1 and x2 are features or the data, and the C1 and C2 are classes. We model it just like that, okay? We can create the fourth class for a given x1 and x2, but in this case we propose two classes, and so then we can write the specific formula just like this one. For the formula P C1 for a given x1 and x2 values, which is given in here just like this one. Firstly, x1 C1 times x2 C2 times P C1 and P x1 times x2. Okay. These are the independent properties, and also we can write the C2 for a given x1 and x2, which is equals to the what? P x1 for a given C2, P x2 for a given C2 times P C2 times P x1 times P x2. Okay. And also we should write to the what? The likelihood, just like this one. Pxi for a given Cj, which is equals to 1 divided by square root 2 pi times sigma j square times exponential term, this is the normal distribution, minus xi minus mu j square times divided by 2 times sigma j square. Okay, and so we can calculate the C1 probability and C2 probability for a given x1 and x2 based on these features. But what is the meaning of this? In this multiplication represents or coming from the what? The assumption of independent property or the features, which means that these two cases or the events are distinct events, and so we can multiply it easily, just like this one. If the x1 and x2 or the classes are dependent each other, we cannot do that because we have the intersection point on this case. So in Turkish, şimdi bakın arkadaşlar, biz Bayes teoremini öğrendik ya, burada iki tane daha kabulle biz bunu artık bir sınıflayıcıya çevirebiliyoruz. Classifier'a çevirebiliyoruz. Bu ne demek? Bizim şartlı bir bağımsızlığımız var burada klaslar için. İkincisi, klasların hangi oranda biz burada gerçekleştiğini bilebiliyoruz. Şimdi dikkat ederseniz bakın, burada C1'in x1 ve x2'ye göre aslında değeri Bayes teoremiyle hesaplanmış. Ama burada bu sefer artık x1'in önsel koşulu ve x2'nin önsel koşulu ikisinin de sağlanması gerekiyor. Yani sizin x1'iniz 1 oranında, x2'niz de 0.5 yani %50 oranında sağlanıyorsa bunun olasılığı zaten düşüyor arkadaşlar. Ama daha da önemlisi, eğer ki bunlar ayrı, independent'sa, bağımsızsa birbirinden, biz bu likelihood function'ları birbiriyle çarparak aslında bu classifier'ı bulabiliyoruz. Yani artık bizim o ilk kezdeki gibi değil, ikinci kezdeki gibi şöyle bir x1 bir de x2 verimiz var. Şöyle verilerimiz var. Artık biz bunları ne yapabiliyoruz biliyor musunuz? Bütün alanın bunlardan oluştuğunu söylüyoruz. x1 ve x2 burada oluşuyor. Ve bir şeyin C1'in içerisine, C2'nin içerisine girebileceğini aslında iki tane değerle. Mu2 mesela bu. Bu da mu1 oluyor. Ama x1'in. Bu da x2'nin oluyor. Aslında iki tane değerle yapabiliyoruz. Eğer biz bu formülasyonu uygularsak arkadaşlar, bu naive yani aslında güçlü assumption'lara yani kabullere sahip sınıflayıcıyı yaratabiliyoruz arkadaşlar. Şimdi bakın, bugünkü dersimiz bununla alakalı bu kadar. Şimdi bir ara vereceğiz. 7'yi 5 geçe bu sefer bunların uygulamalarını yapacağız arkadaşlar. Yani bunu sınıflayıcısını nasıl yapıyoruz, nasıl ediyoruz? Biz bunu tartışacağız. We have a break right now guys, and so we will start at the 7:05 p.m. Okay?